The last part of our section is to look at how do we obtain the graph of the inverse of a function. The inverse of a function has the roles of x and y reversed. So if a comma b is on the graph of f of x, then b comma a is on the graph of the inverse. This also means that the graphs of f and f inverse will be symmetric with the line y equals x. So example 7, let's use the graph of f of x to obtain the graph of the inverse. So here's the graph of f of x, and what you want to do is first make a note of what are the important points of this function. Okay, they're labeled on here, -3, -2, -1, 0, and 4, 2. What this means is, if these points are on the graph of the function, then for the graph of the inverse, instead of having -3, -2, we'll have the point -2, -3. Instead of having -1, 0, we will have 0, -1. And instead of 4, 2, 2, 4. So if I graph these points, this will form the graph of my inverse. So -2, -3, 0, -1, and 2, 4. So if we connect these points, we get a graph that looks like this. Okay, the other property we get, and we can observe this here, is that the graph of a function will always be symmetric with its inverse across the line y equals x. The line y equals x is a line with a slope of 1 and a y-intercept of 0. So it's a line that looks like this. And notice on either side of this line, we have the graphs identical to each other. And so we can fold along that line and have the two sides match up.